Hey guys, Mrs. Rust here. I'm just going to make a quick little video for the nitrogen cycle for you. The nitrogen cycle, I find it's just a little bit trickier for students to understand because there's so much kind of complicated stuff going on in the soil with bacteria, and also dealing with both free and fixed nitrogen. So I'm just going to talk through some of the terms and then just draw the cycle out with you. What I would strongly recommend is drawing this along with me, as if you're taking notes in class. Drawing out the cycles can really help just to solidify it in your head, and also if you go back to practice later and draw it in your own way, that can be a really helpful way to study. So let's start with some terms. So free nitrogen is what we call the nitrogen when it's in the atmosphere. And so this type of nitrogen is always N2 gas, and that's about 70% of our atmosphere, even slightly more. I think it's more like 79%. So most of the nitrogen is actually just floating around in the atmosphere. It's not useful for organisms in this form, and that's why we call it free. Basically, this nitrogen just floats about and it doesn't have to become a part of the food chain. It just hangs out and does its own thing. So what we want to have happen for the food chain and organisms to be able to use that nitrogen is we want it to become fixed. It doesn't mean that it was broken as N2 gas. It just means that it wasn't really useful for organisms. So when that nitrogen is fixed, it's in a more solid form that can be taken up by organisms. The main one that we really like is nitrate, which is NO3, nitrate. And this dissolves really well in water. It can move through the soil easily. And this is the favorite for plants. This is their favorite way to take up nitrogen. So that's usually our end goal with fixed nitrogen. We want it to turn into nitrate. Then it can get assimilated into plants. Assimilated, you might have heard that term in social studies, where something is becoming more like a larger group. So this nitrogen, NO3, is becoming more like the nitrogen in the plant's body. And so, well, body, you know what I mean, it's leaves and stuff. So it's getting turned into the proteins and the DNA in the plant. Once it's assimilated into the plant, it could get assimilated into an animal. If that animal gets eaten by another animal, it can keep passing through the food chain in this way. And eventually it will become decomposed. And so that is how it will eventually return to the soil. The other types of fixed nitrogen we have, so we have NO2, which is almost as good as nitrate, just not quite as good. This one is called nitrite. Okay, and really we just look at NO2 in this cycle as a stepping stone to turn into nitrate, our favorite. The last one is ammonia. And so this one is NH3. NH3 is ammonia. NH4 is ammonium, the ion. We're never really going to be too picky about which one you write in your own cycle. Okay, so ammonia, you guys might remember talking about that when we were talking about the excretory system. It's something that's made from proteins when they get broken down. It's a waste product that's really toxic, so oftentimes it needs to be broken down into a safer form. In your body, it gets broken into urea, and then if you were to, pee on the ground or something, bacteria can turn it back into ammonium, and then usually another type of bacteria will turn it into nitrite, then nitrate, the most useful form. So I know already some of you guys might be thinking, whoa, this is too much information, but we're going to look for where we can see all four of these types of nitrogen in a bigger cycle. Okay, so let's start with the atmosphere. we're going to make some free nitrogen that's just floating around happy in the atmosphere, not getting used by any organisms yet. So the way that we get it from the atmosphere down into the soil where it can be useful is we need to take that nitrogen from free and fix it. So one of the coolest ways this happens is through lightning. So if you have a lightning storm, it's actually really good for your plants because when the lightning strikes, it gives enough energy to the molecules in the air that it splits nitrogen. It splits N2. And what nitrogen looks like as N2 gases, it actually has 3 bonds. So it's a really strong bond. If we have nitrogen striking that bond, it can break it apart so that we just have nitrogen floating around. Now, those of you who are familiar with chemistry, you know that if something had a bond and it's broken, usually that atom will want to bond with something else, or that ion. So the other thing we have lots of in the atmosphere is oxygen, which is O2. Oxygen is a little less securely bonded, but that can also get broken by lightning. Or it gets broken in this process basically. And so oxygen can react with the nitrogen and then we get NO3 eventually. Okay, that NO3 nitrate is now fixed. And so we call this whole process nitrogen fixation. Okay, so this fixed nitrogen, it's now a little bit heavier. It has some oxygen added in. And so when precipitation comes, usually during a lightning storm, that precipitation can help that nitrate to fall into the soil. And now we have NO3 sitting here waiting to get used by plants, and it can enter the food chain. The other type of nitrogen fixation that we have is through legumes. And legumes, they're a group of plants that have root nodules, which are like little knobbies that are full of bacteria on their roots. Okay, so I'm going to draw kind of a little simple leafy plant, and then on its roots we're going to add some little knobbies, root nodules. Okay, the legumes, that is a group of plants that includes things like alfalfa and clover, as well as any of your plants that are kind of like peas or beans are going to be a type of legume. So these little knobbies on their roots, they look like they might not be great. They kind of look like an infection or something if you don't know what you're looking at. But these nodules are full of helpful bacteria. And inside of these nodules, if we were to zoom in, these helpful bacteria, they help to convert N2, so that free nitrogen gas that's not useful in its current form. They take that N2, rip it apart similar to what happens in the lightning here, and they combine it with oxygen and again form nitrate. Okay, so this bacteria, because it's forming nitrate, we call it nitrifying bacteria. Okay, nitrifying bacteria make nitrate. So those nitrates can now be taken up by plants, and so some of this nitrate will actually go into the legume and it becomes assimilated. It becomes a part of that plant's proteins and DNA. And so we would call this a symbiotic relationship between the bacteria and the legume plant because they're helping each other out. Okay, so that's kind of the first starting point. Now we have nitrate in the soil, And so it's going to be assimilated into any of the plants that are there. And I'm just going to use different color for assimilation. Okay. So we're taking that nitrogen up. It gets assimilated into the plant. Let's take some of these nitrates and put them into a bigger plant too, just because I'm going to run out of room here. Okay, so we're going to show some of these nitrates getting sucked up into a tree. They'll become a part of the proteins in the tree. And then if we want to get nitrogen into animals so that they can use it for their proteins and DNA, the only way that the animals can get nitrate is by eating plants. Okay, and so that's one of the many reasons you should eat your vegetables. I'm just drawing an animal here. I'm going to draw a giraffe so that he can reach up into this tree. Okay, one of the many good reasons to eat your vegetables is we need nitrogen for our all of our muscles and our DNA, virtually every part of our body. And so plants are very high in nitrogen. You can actually also get nitrogen from eating meat as well, because that nitrogen is going to become a part of that animal. Okay, so this arrow should be purple as well, going into this creepy looking giraffe here, because this is also going to be assimilation into his proteins and DNA. Okay, so there's nitrogen inside of the giraffe as well. Okay, and so if something eats the giraffe, they'll get his nitrogen. Otherwise, when the giraffe is making waste products, so any sorts of waste, they're going to have nitrogen in them as well, including urine, which is going to produce urea. This is a really gross looking picture now, isn't it? Okay, and so that's how we can get nitrogen back into the soil. Okay, so to become useful, oh, actually there's one other way too. Eventually, if this giraffe doesn't get eaten by something, he's going to pass away. And so if we have a dead organism here, that eventually can decompose as well and return nitrogen to the soil. Okay, so no waste here in this process. Everything's getting recycled. Okay, so over here we have death, decay, decomposition. All of those processes are helped along by bacteria, and sometimes fungi and other decomposers as well. Okay, but we're going to focus on this new type of bacteria here that would be called ammonifying bacteria. Okay, and so ammonifying bacteria, you guessed it, they produce ammonia. And H3. Okay, because there will be whole proteins still in this organism that's decaying, as well as some of the waste products. And so we have to turn that just into ammonia so that it can become useful again. Okay, so the ammonifying bacteria turn this into ammonia. Ammonia is not our favorite source of nitrogen to put back into the food chain. So this ammonia needs to get turned back into nitrate by the nitrifying bacteria. Nitrifying bacteria. Okay, so they do the exact same thing as they did before, they're just using a different source of nitrogen this time. So they're using the ammonia and they turn it back into nitrate. And that nitrate can again get assimilated and put back into the food chain and can get sucked up by a plant again. Okay, so at this point, some of you might have totally forgotten that there's also nitrite. That's another stage or another type of nitrogen. Nitrite, I usually just kind of ignore it when I'm teaching the nitrogen cycle because it's such a small component. As we're going from ammonia to nitrate, we actually have a little stop where the bacteria will turn the nitrogen into nitrite, and then they just add that third oxygen and turn it into nitrate. Okay, so that's just kind of a side step, still done by the nitrifying bacteria, but you don't really need to know about that too much. Okay, so from here, as we're looking at where the nitrogen is going, it actually stays in the food chain. It can just kind of go around and around. This nitrate will turn back into the tree. Tree can get eaten by the organism. Waste products get turned into ammonia, and then the ammonia turns back into nitrate, and it just goes around and around in the food chain. Okay, so this isn't really a full cycle. If that was all that happened, eventually we could run out of that free nitrogen in the atmosphere and it would all just be trapped in the food chain. Okay, oh, that is not what I wanted to do. So there's one more stage of the cycle that is kind of strange. So we have one last kind of bacteria that is kind of a jerk because he undoes all the hard work that we've done to fix that nitrogen and keep it in the food chain. And this is called denitrifying bacteria. So denitrifying bacteria actually hates oxygen. This type of bacteria, it's called anaerobic, which you guys might remember from cellular respiration, does not like to be around oxygen. So this bacteria likes to hide in usually kind of old soil that's been compacted, doesn't have a lot of oxygen. And what it'll do is it actually takes nitrate and it turns it back into N2 gas. And so it's kind of just a bully that's defeating all the hard work of the nitrifying bacteria. Okay, so let's just do a little shortcut here. Let's say that some of this ammonia got turned by the nitrifying bacteria into nitrate, NO3. And that nitrate gets eaten up by this denitrifying bacteria, and he turns it back into free nitrogen. Okay, and now that free nitrogen, it just goes back into the atmosphere and it hangs out there until one day it might get fixed again. Okay, and so the denitrifying bacteria help to make this really a cycle. And that's about everything you need to know. So again, some of you are like, oh my gosh, that's way too much that I need to know. The biggest things that I'll kind of point out to you. So nitrogen fixation is really important. You need to know that that is turning N2 gas, which is free, into the one of the fixed types of nitrogen, so the NO3 nitrate. Okay, the other thing you really need to know is that nitrates are the favorite of plants. That's the ideal form that we want to be able to assimilate that nitrogen into the plants, and then it enters the food chain. Okay. You do need to know a little bit about the ammoniifying bacteria, ammonia, all this stage here. Okay. But the bigger thing you need to know is how this whole thing turns back into a cycle, and so that those denitrifying bacteria, oh, sorry there. A little phone call from my mommy. I'm just going to hang up on her because I'm that kind of person right now. This is more important. So that denitrifying bacteria will turn it back into free nitrogen. Okay, so if you know kind of those big points, what types of bacteria are doing what, you should be well set for the nitrogen cycle.